włożyć jakiś... Tylko nie wiem, co tu wejdzie, za gruby tutaj nie wejdzie. No tak, no przylutować tutaj nie bardzo, bo nam to będzie za delikatne, to odpadnie. Ja to bym tutaj coś wlutował, włożył jakiś drucik, tutaj cyną fajnie zalał solder maską i na tą solder maskę tak go poskręcał może, o, żeby to tak, no nie wiem, taka trochę rzeźba, ale chyba taka...
What? A wire? Sweet Jesus in strawberries. Hello Internet. Today we will take out the button signal from Citroen C5 steering wheel buttons for a gate remote control. We will do this in the way that doesn't cause pain in the chest, and it won't be one button but 4. The voice assist button, the high beam flash lever, but not the high beam switch, the left back for the cluster menu, and the right back for the radio menu. What will we need? Arduino Nano. Indestructible MCP 2515, better than sliced bread. Relay for a contact switch. And something to convert 12 volts to 5. I will just take this and that. I will just put this together according to the diagram. So it's about 20 minutes of soldering. I will not connect the relay for now. For test I will use LED array that will give us a better view of outgoing signals, which you can see instead of hearing a relay click. So relay is for you to solder. Let me just clean up and connect the LEDs. As for the steering wheel switch, we are connecting to existing loom. All 4 wires. Yellow-green negative, violet positive, twisted one CAN bus. In this case, green CAN high and red CAN low. I've also got the pecan connected, because the buttons without CAN bus network won't turn on. Just like a Renault cluster. You can connect the boards with DuPont wires, but as for something that goes to the car, it's better to use soldering. I will take the power supply from the USB, but in the car you got the step-down converter to power from 12 volts. I've got the pecan running. I'm sending the maximum brightness and ignition status. I will move this to the side and connect the LEDs with logic analyzer connectors. They got tangled as always. Just give me a second to untangle this. Something fell off. That's not good. Okay, we got our 4 connectors. Connect the common ground, and our outputs are D4, D5, D6, and you guessed it, D7. I will talk more about the program when we go to the computer. Now we will test if it works. Arduino in the receive mode is looking for 2 CAN frames. When it sees them, it's waiting for appropriate bits. When it sees the bits, it's changing the outputs. And that's all. Whatever we connect to the outputs, is it a relay or something that can receive the voltage, it doesn't matter. So let's test. Voice assist button works. High beam lever works. When you push hard, it also activates the push low function. So the car will change from low beams to high beams, but it doesn't matter for us. The left back button is also working, and the same the right back button. Of course, we can choose one of those 4 buttons and connect this to our gate remote control, or we can use all 4 for different functions. I've coded all 4 for convenience, just not to tinker with the code. The horn button is also a CAN bus signal, so it's something for the future. Of course, all the buttons work independent, so we can use the combination of the buttons. I'm missing the 3rd hand. Woo. So you have no limitation in use of this. As you can see, I've changed the background, just added a subscriber counter. It's pulling live data from YouTube API and displays it on the video. So if you want to subscribe, no problem, thumbs up and comments all are welcome. So now we can go to the boring stuff, the computer and code. But it's good to know what are you running on your car. So we start with adding the libraries. Then we create the CAN frame and we set up the chip select pin. Then we create all the buttons and outputs and we define the bits. In setup we set the outputs. The serial begin we can comment out. it was for debugging. We reset the MCP 2515, then we set the bitrate of our CAN bus. I was experimenting with the modes, and the listen only mode seems to be working fine. And we start the main loop. We're reading the frame. If the frame is 094, we copy the first byte. If our frame is 082, we copy the second byte and the fifth byte. We extract the first bit from our byte, and we extract the fourth bit from the same byte. The same way we extract the other bits. The next step is to compare the bit. If it's high, we set the high output. If it's low, we set the low output. And we do this accordingly to all 4 bits. And that's basically it. I will leave the code in the pinned comment for you to copy and use as you wish. I encourage you to comment, like, share, subscribe, and I hope Fabi won't be mad at me. So see you next time, bye.